Hello everyone! In today's video we will go over 10 most common SQL interview questions and what are the best answers for these. Now I'm a recruiter, I've done hundreds of interviews for data science and data engineering positions, so SQL is a must for these. And I have just looked it up on the internet, like what are the most common SQL interview questions, and I must say, some of them I ask, some of them I don't ask. However, let's go through them and let's see what they are. First off, for the questions and for the explanations, I will be working with a very simple data model. We have an departments table, we have an employees table, and then just some data inserted into these tables. First off, what is SQL? What are its different types? I don't think it's a very good question. I would never ask it. However, here you go. So structured query language, SQL, standard language for managing, manipulating relational databases, and there are different types of commands, right? So we have the data definition language, essentially used to create, alter, drop tables, and you have data manipulation language, select, insert, update, and delete. And I would say on these two, your knowledge can end because nobody knows that something like data control language exists. I mean, people know that grant or revoke exists, of course, but nobody knows that it's called the data control language. Same for like transaction control language. So you need to know what is a commit, what is a rollback, what is a save point. However, you don't need to know that the group is called transaction control language. Second one, what is the difference between a join and a union? So it's very straightforward. Join allows you to add columns from one table to another, and a union allows you to add rows from different tables or different select statements together. Right, so here, let's say we have a very simple join that joins departments table and then left join to the employees table, and we are selecting the department name and the employee name. And below that, we have a union. So we are selecting the department name from the departments table, and we are selecting the employee name from the employees table, right? So here, resulting dataset will have 2 columns, and here resulting dataset will have 1 column, which doesn't really make much sense. However, this is how it works. If we now run it, we can directly see the first query, we have the department name and the employee name, and then second query, we just have 1 column with the names of the employees and then the names of the departments. With union, what you can also have is union all. The difference between union and union all is that union would delete the duplicates. So if you, for example, had the same query here twice, and then just did a union, comment this out, let's run it. What you would have is the department's name only once. But if we had a union all, and I would run it, we would have the department names twice. It's a nice, cool trick to remove all the duplicates. Third one, what are the different types of joins? And this is a common question. I would ask this question in a beginner level interviews, and there are 4, like only 4, not 17. This is a left join, this is a right join, this is an inner join, and a full join, also sometimes called full outer join. So first off, a left join, the most commonly used. Essentially what it does is it takes all the rows from the departments table and returns the matching rows from the employees table, right? So what we can directly see here is if in the departments table we have an IT department that has no employees, this will just show up as null. Whereas a right join, let's go to the right join. Let's say we have an employee that doesn't have a department, right? So a right join takes all the records from the left join and adds all the matching records from the departments table. So if we have an employee that has no department, it will show up here, while it did not show up here in the previous query. However, if we have a department that has no employees, it will not show up in this query. So a right join and left join are the opposites. If we switch the tables right here, we will exactly get the previous query. Now an inner join. So an inner join only takes the matching rows from both tables. So essentially, if I now execute an inner join here, you can directly see we are missing the guy who has no department and we are missing the department that has no employees because it selects only when there is a match. And then the last, full join. So what full join does is it selects everything. All the rows from one table and all the rows from the second table. So you can directly see we have both all the matches, and then we have the department that has no employees, and then we have the employee that has no department. Now, a more advanced version of this question is an ask about database join algorithms, right? So this is where you would suppose to go into nested loop and hash and sort merge. I have a video about that is currently showing up on your screen, but this I would ask only in interviews for more advanced positions. Fourth one, what is database normalization? Database normalization is a principle of database design that allows you to enhance data quality, integrity, and limit the redundancy. So as a result, limit the space that you need to store it. Essentially, it's described by these normal forms. So you have like 1, 2, 3, 4, 5 normal form, and then some additions into that. It's a little bit theoretical, I feel like. I don't like asking these questions, but in the end of the day, it's important to understand. However, I always feel like it's kind of common sense, right? So they are kind of ascending, right? So 1fn is, so for something to be 2fn, it has to be 1fn plus something, right? And these are like the principles of design. Now, why, when a table is not in the first normal form, this is when you have a column in a table that is entirely dependent on a different column. So let's say in our employees table, I'll try to show it to you a little bit better. Let's say that in our employees table, right, we have a column that is called salary, and then we have a column that's called monthly salary, which is obviously the salary divided by 12, right? So this is the yearly salary, the monthly salary is just salary divided by 12. If you have such situation, the table is not in the first functional norm. A second case can be that we have a situation like this, where we have a one employee and then we have like 2 departments, right? Doesn't make sense currently, but if you have a situation where you are storing in one column, in one row, more than one value, like in comma delimited or something, this is not a first normal form. Now, risks of such design, of course, you have redundant data, right? If you then update the salary, you can forget to update monthly salary and you have a problem, right? And then these column, like these department IDs, if you have multiple values in one row, this is super difficult to work with, right? If you really wanted to fix that, this should be additional records if someone really works in 2 departments, like let's say 50% in each. Now, second normal form. This is where it gets a little bit more complex because we say, okay, if we have a primary key of a table, all the columns from it need to be dependent on the whole key because a primary key can have more than one column. And if we have a situation like we have right here, where the employee ID is not unique because only the combination of the employee ID and the department ID is unique, then all the columns of the table should be dependent on both of the values. So for example, we cannot have a situation like this where we have department ID and then department name, because the department name is only dependent on the department ID. It's not dependent on the employee ID. Therefore, if we have a situation like this in our data, our table is not second normal form. It's not in the second normal form. And to be in a second normal form, we cannot have situations like that. Plus, we have to have also the requirements for the first normal form fulfilled. Now, the third normal form, this is where we say that we cannot have duplications. And by the way, going back to second normal form, if you have a primary key that is only one column, like an ID usually is, then it's automatically, and it fulfills the first normal form, then it's automatically second normal form. But if you have a third normal form and we have a similar situation like here, or if we want to be consistent with the third normal form, we have the employee ID here, and then we have the department ID, and then we have also here the department names that I forgot to add here if I wanted to execute it. And this is against the third normal form, so a table like this wouldn't be in the third normal form because we have the department name that is dependent on the department ID. However, the department ID is not the primary key of this table, it is the employee ID. And always where we have kind of the department ID 3, it will always be finance. So this should go to a separate table as is in our testing setup. By the way, a link to the testing setup is in the description of this video. Right, so if you wanted this data model or this table to be in the third normal form, only you should keep the department ID here, and the department name, and the relation between the name and the ID should be in a separate table. Once again, This is because if you want to change the department name or change the ID for some reason, you would have to do it kind of in multiple different places, right? Because if you say change finance to, I don't know, finance 2 or whatever, you would have to change it in all the rows where the department name is finance or the department name is 3, and not only in one place if you had this in a separate table. Now there are also 4th and 5th and boys code, but this is all kind of getting more and more theoretical, and I will say more and more magic than practice. However, if you get a question about normalization, normal forms, this is how you should answer it, and I believe this answer will be absolutely correct. Next one, what is the difference between where and having statements? So where is applied on the source dataset, and then the having is applied after the data has been grouped together and the summarized functions have been executed. So essentially what it means is that if I, let's say, select the employees where the salary is higher than 60,000, right? And I run both queries. We take a look at the first query, it will return me all the employees where the salary is higher than 60,000, and if someone has a salary lower than 60,000, it will not be taken into account. Now let's say I want to ask a different question, right? I want to ask a question, I want to select all the department IDs where the average salary is bigger than 60,000. So what I have to do is I have to do a group by, and the having always goes with a group by. So we are selecting the department ID, then the average salary from the employees. We are grouping by department ID, and only after the data has been grouped, we are selecting only the departments having the average salary higher than 60,000. We can see we have 3 departments like this. So once again, if I had a group by right here, it would be applied. So the query, the actual exclusion of records would be applied before the group by, right? So if we did like group by department ID, right? And now I would select here the same values essentially. So now what is happening here in the first query is that we are calculating an average salary of employees, however, only after selecting only employees for whom the salary is higher than 60,000. So this is kind of a salary average of people who are already above average. Because if we take a look right here, we can see that, for example, I don't know, like department 3 has 68,000 and here department 3 has like 72,000, right? Which is obviously incorrect. And this is because here where was applied before the group by and before the average was calculated, and the having was applied after group by and after the average here has been calculated. What I like to do is, I like this question and I also ask it. However, what I would also follow up with is kind of understanding in which order exactly are the statements executed. What is a primary key and what is a foreign key? So these are both types of keys that we have in the database that allow us to maintain referential integrity. Now the primary key uniquely identifies a row in a table. So you define it when you create a table, or you can also alter it afterwards. However, a primary key is a not null column where each value can occur only once. So the values have to be unique, and it uniquely identifies as a row. So if we have any value of the department ID here, taking as an example this departments table, if we have any value, so like 1, 2, 3, 4, 5, it will have the value only in one record. It automatically creates also an index underneath the primary key. Then if we move to foreign key, so let's take a look at this example. We have the employees table and we have a foreign key on the department ID column that references the departments table that we have above here and the department ID column on it. So this means that I cannot insert a record in the employees table where the value of the department ID doesn't exist in the departments table. And this is essentially what it does, right? So if we have an example, I have the following 5 departments, and then I wanted to insert a record into the employees with the department ID 6 that does not appear here. And if I execute this, we will get an error saying that an insert or update on table employees violates foreign key constraint, employees dept ID foreign key. Now, I would also get an error, right? If I comment this out and bring this back. If I wanted to insert something into departments where the department ID is a null value. So if I run this, we will also get an error that a null value in column dept ID of relation departments violates not null constraint. So this is exactly how this works. Next one is a question to select second, third, whatever highest, lowest value in the table. And this you can do in two different ways. I think the first one is very clean. So let's say we should select a guy who has the second highest salary, right? So what we do is we are saying select me everything from the employees table, order by salary, descending, of course, and then limit one. So display only one. This is in some databases called fetch first, like 1, 2, 3 rows only. And then we have offset 1, which means like order by salary, give me only one, however, not the first one, but offset by 1, so give me the second one. And you get this David guy who earns 80,000. And you can also do it the second way, but this only works if you have like second, because in this way you would not select a whole guy, also you just select the value, right? So what we are doing is we have a subquery, we are stating where salary is smaller than the maximum, and we are selecting a maximum out of that, right? So a maximum of something that's smaller than maximum is of course the second value. We will get 80,000. However, I think this is far better than this one, because this easily allows you to go like offset 2. This would give you like the third person, right? And if you get like offset 3, it will give you yet another person, offset 4. It will give you yet another person, right? So essentially what it does is allows you to be very flexible. And if you want to select the lowest, you just remove the descending. Now you have the ascending order and you have a different person. So now it's like 5th lowest, I believe. Now, what is an index in a database? So essentially an index is a data structure that improves query performance. It's usually a B-tree structure. A B-tree is a data structure that is underneath. And how you create it is essentially you say create index and then index name on what table and what column. And the indexes can be unique, right? Then they form a primary key on a not null column. And this is the most important, the second function. So the first function is they can improve query performance, so they can improve your selects. To a certain degree, they can also improve joins. However, they slow down updates, inserts, and deletes. They can enforce query unique constraint. This is what we already said. And they are automatically created if you create a primary key on a table. Now, I have a whole video where I go in depth about indexes. It's currently showing up on your screen. It's also linked in the description down below. What is a stored procedure? So a stored procedure is just a piece of SQL code saved in a way that you can really easily reuse it, right? So if you have some logic that you want to be reusable for you, you can just create a procedure or a function. Now, this is heavily dependent on the database that you're using. Here I'm on Postgres, so the syntax looks a little bit like this. So more or less what this function does, it returns as a table of people whose salary is higher than the average salary in their department, right? Oh, so let's say relatively complex part of logic. It can take an input, it produces some outputs, right? So in our case, it takes the department ID as an input and it returns as a table that has the employee name and their salary. And then how you call it, however, once again here, it's Postgres way of calling it. Like if you go to a different database, it will the syntax here will look differently. And not always you can just call it like that. I guess Postgres is one of the most convenient in this case. So if I just run this piece of code by accident twice, what you can see is that with the department ID 3, I get like these two people. And then if I move to the department ID, I just get our David that we have already seen before. And the 10th one, what is the difference between delete, truncate, and drop? And this is, I like this question. I think it's a nice question because it has a very common misconception. So first off, delete removes rows from the table, truncate also removes rows from the table, and drop removes the whole table. So essentially you have like delete and truncate, which remove records, and drop drops the whole table, right? So after delete truncate, you will have an empty table. After drop, you will have no table. So first of all, a delete. A delete also allows you, that we have it here, also allows you to specify a where clause. So you have delete from employees where, I don't know, where salary is lower than, I don't know, 10,000, right? We want to remove the employees earning the least. For some weird reason, this works just fine. This you can do, no problem. With truncate, you cannot add a where clause. Truncate always remove all the records. However, right now, and it goes to the transaction topic. If you begin a transaction, in Postgres you just say begin transaction, then select count from employees, delete from employees, delete without where, so deletes all the records, select a count. Once again, this should be 0, and then make a rollback. Let's see what happens. So first off, we have the transaction begin, then we have the count, right? The count is 11, that's how many records we have. Then we have the delete, successfully executed. Then we have the count, which is 0, so this is this count. Then we have a rollback, successfully executed. And then we have once again a select, which once again gives us an 11, right? And essentially, this means that we have deleted all the record, then we have rolled back our transaction. And if you want a video on the transactions, just leave me a comment down below. I'm happy to do it. However, we have went back in the state of the database to the moment where we said begin transaction. If I said a commit here, this would essentially, so if I said a commit and I run it, then I have the first count, it's 11, then I have the delete, then I have the second count, it's 0, then I have a commit, and then I have a select, which is 0. Now to the truncate, I will just recreate the test data. Now a truncate. And here I have the exact same setup. Begin transaction, truncate, select count from employees. Maybe I'll just add a count also here. Rollback, select count from employees. Now a common misconception is that many people, I have heard it many times, say that a truncate is not something you can roll back. So it's not part of a transaction. And this is only partially true because on some databases it is and on some databases it's not. Or maybe I should rather say some databases allow you to roll back some DDL statements. And truncate is considered to be a DDL statement, so a data definition language statement, and some don't. Like I'm on Postgres, and I guess we will see what happens. I know what will happen because Postgres allows you to roll back a truncate, meaning first count is showing 11, then we have the truncate, then we have the second count, it's showing us 0, of course, because we are still in one transaction, then we have a rollback, and then we have the next count, which is showing us 11. Right, so here we have an example where we were able to roll back a truncate, and this is a common misconception, please do not make this mistake. The difference between a truncate and a delete then is delete allows you to add a where clause, truncate doesn't allow you to add a where clause, and truncate is much faster because it does not scan a table. And there's one more difference, truncate doesn't save the delete in the database log, meaning if you truncate something and you commit the transaction, it's irreversibly gone. Now drop, and drop is really different from the two before because it really removes the whole table, right? However, I would just like to show you the same thing I have showed you already. If we write something like this, this will work without an error. Why? Because a drop table in Postgres is something you can roll back. So what we can see here is drop table, then we can have a rollback, and then we have a count on the table that we have just dropped. So essentially, you can see that in Postgres, you can do it. Not in every database management system you can do it, right? So I think in Oracle, you cannot do something like this. But if we set here commit, right, and we execute it, our block of code, we would get an error because the relation employees doesn't exist when we try to select rows from it. That's all for today. Thank you very much for watching. On your screen right now, there are two very good videos that will definitely help you in your interviews. One is about database partitions, something that we haven't touched in this video, and the other one is the video I already mentioned about the indexes. If you are preparing for an interview or you want to improve your SQL skills, please do watch these videos now. See you in the next video.